Hi, everyone. My name is Marcela Granados. Welcome to the NLP session on automated extraction of medical risk factors for life insurance underwriter. I am Databricks Global Insurance Leader. I am an actuary and data scientist by background, and I'm here joined by my colleague, Mohammed.
Hello, everyone. I'm Mohammed from Johnson Labs. I'm working as a data scientist in a healthcare team. So I'm happy to share this presentation with Marcela.
Awesome. So let's go ahead and get started. So underwriting for life insurers is one of the core pillars of growth, especially after the pandemic. And what it involves is just deciding which risks to accept, how to group them, and eventually how to charge the right premium associated with the risk class that they represent. This is normally done by mortality studies conducted by actuaries for many different centuries. And actuaries normally look at factors like your age group, your gender, and whether or not you're a smoker. So, what has changed? Well, the key is that life insurance underwriting is going through a major digital transformation where both customers and insurers want to do it faster, better, and more accurately to what it's called accelerated underwriting. So all this means is that we are now leveraging data outside of your structured data as well as complex analytical techniques to assess the true policyholder risk quickly and determine ultimately who would need to get a blood test or a urine test, which, as you can imagine, is invasive, intrusive, and expensive. So why is this so hard? Well, these risk factors are normally provided inside text documents. So think about your electronic health records. Depending on how healthy you are, you may have hundreds of pages of electronic health records, or even the prescriptions that you will get from your doctor. And depending on your doctor, the handwriting may be really crappy. So the fact of just even trying to digitize that information is not that easy. Luckily for us, there are new insurance-specific NLP models that can automatically extract all of this medical history, all of these risk factors from those documents, and use that to augment what you would normally get from your unstructured data to correlate that with mortality and provide a more accurate risk assessment. What is the benefit? Why are we even talking about doing this? Why change the way that we've been doing things for decades? Well, according to the NAIC, the National Association of Insurance Company, you can shorten the end-to-end underwriting process anywhere from 2 to 12 weeks to less than 48 hours. And that's just being conservative. Next slide, please. So how do we do that? How are we able to take accelerated underwriting through a real life example? Well, let's look at a simplified life insurance ETL pipeline. The key is to start with ingestion of your data that's actually going to be needed for the analysis. So to supplement the information on your basic profile, I mentioned, your age group, your gender. You would have smoker in a very binary way. Normally, you ask somebody whether or not they're a smoker. And if you're lucky, you may get your weight and your height to derive what your BMI may be. But that data is just the basic profile. What we will do is supplement that data with all of the unstructured data from different risk categories that we know are going to be predictive of mortality. So think about your personal medical history, your prescription, diagnosis. We can even take it one step further and think about genetics. What is your family history on some of those diseases? That is coupled with information around your lifestyle. So think about how frequently do you drink? Are you really a social smoker? Do you vape? And correlate that with diseases that people may develop later in their life. So this is very important because we're not just looking at how your personal medical history and your lifestyle is affecting your mortality today, but we are taking it one step forward and thinking about like how what you're doing today is going to affect your mortality in the future. So this is truly predictive, because now we have line of sight as to what are the diseases that you may develop later in your lives: high blood pressure, heart disease, cancer, and even anxiety and depression, which is not just something that it's becoming very common nowadays, and it's not very quantifiable and objective. So this is very, very important. So once we digitize that information, we move it through the ETL data pipeline. We can store it on your S3 bucket. If you're with AWS, maybe you store it in ADLS. If you're with Azure, depending on your cloud provider. If you're even on the cloud, hopefully you are. But after that, we run it through what we call in the medallion architecture. So this is more of a Databricks Delta term. But all it is that the raw data would first land into your bronze zone. So again, this is just the raw data once you're digitizing all of that information and you move it out of the object storage. And from there, we run the usual NLP process of tokenization, hashing term frequency, doing word to back, because of course we know that feature engineering is better to do it with vectors rather than with words. And once you're done with the feature engineering to transform your data, that data moves from the bronze zone to the silver zone. Mohammed will show the complexity of this process, right? So anybody that has done even the basic NLP will be familiar with this, but I cannot stress enough how this is a very complex process. There's a lot of work that had to be done with normalizing that data, running your ontologies, looking for synonyms, grouping entities, and leveraging NLP libraries that are built by John Snow Labs that they leverage a lot of the subject matter expertise from clinicians, not normal people like you and I, but people that actually know the field very well, to know what to look for in these documents, so we can actually do this right. So once you are able to correlate your risk factors with the future mortality, your data now moves from the silver zone to the gold zone. And now it's ready for reporting. Now it's ready for dashboarding to ultimately be coupled with the usual underwriting business rules on deciding who is eligible for coverage, whether or not the risk need to be further review by an underwriter or some other specialist, whether or not you need to conduct those additional blood and urine tests, what is the coverage that this person may be having, or whether or not you need to do straight to process, in which this case is something that companies are trying to optimize the rate of straight to processing because they want to automate as much as possible, which risk should be eligible for coverage. So with that said, I'll now hand it over to Mohammed, who will cover the details on the notebooks. Thank you.
Now let's check how Spark NLP for healthcare can be used for extracting the medical risk factors for life insurance underwriting. So Spark NLP, first of all, I want to mention something about the Spark NLP for healthcare library. Spark NLP for healthcare is an extension of the Spark NLP open source project. As you know, Spark NLP open source is highly popular and only scalable NLP library out there, which is downloaded 50 million, more than 50 million times so far. Spark NLP for healthcare extends everything from open source and aims to provide a scalable library. Actually, it's only the scalable NLP library in this domain because it's still on the shoulders of Apache Spark itself. And we aim to be high accuracy, which is always ensuring the best accuracy in academia by using the latest state-of-the-art techniques. And it's private, which means that you can ship the library in your environment even though there's no internet connection or behind the firewalls. It works without any issue with no additional requirements rather than Spark itself. Also, there's no data exchange with the users or other library developers. Another feature is that it is modular, because you can use any components and models in Spark NLP and Spark NLP for healthcare together and build up a pipeline to get better accuracy. It's also tunable. Tunable means you can fine-tune pre-trained models with your data. So far, we have more than 1,000 pre-trained models, and this is just for Spark NLP for healthcare. In Spark NLP open source, we have more than 50,000 models. So you can build up a pipeline with any components of open source and healthcare library together and use any models that you are interested in. Most meaningful, actually working with the clinical text, they are generally in unstructured data format. So we need to get the entities. Entity means the meaningful minimum clinical chunk. We named them as named entities, clinical named entities. And NER feeds all the downstreaming tasks that you might need to use in your workflow. For example, let's say that you may want to get the you are working with the radiological reports, and you want to get the CPT codes of the procedures, right? So you need to use first get the entities, then feed those entities to the entity resolver models, or you may want to check the negation status of the entities. For example, you are interested in that the present entities only. So you can filter them by using assertion status models. Or you may just want to check the entity relationships, if they are in a relationship or not, to connect dots while trying to solve your problems. At the end of the day, we aim to get this picture. As you can see here, the entities are detected correctly, and like this one, this is type 2 diabetes mellitus. This is a disease, and as you can see here, with a history of type 2 diabetes mellitus, so that the assertion status is passed, right? And also we can map it to ICD-10 codes or SNOMED codes or UMLS codes, and this is a clinical finding, right? So you can also check the relationships between entities, like here, the 500 milligram was detected as dosage and metformin as drug. So there may be some other drugs or dosage informations in the same sentence, right? So you need to check the relationships between them, and if they are in a relation, then you can use them together. Like this one, if they are in a relationship, then you can merge them and get the Aristotle code of this drug. Also, we are able to calculate the HCC risk adjustment scores of the patient from using the clinical notes. Yeah, here is our main table. As you can see here, we define some entities to they are related to the medical risk factors, which we can use in life insurance underwriting. Okay, so in the basic profile, we just use NER models and get the age, gender, weight, height, or race, ethnicities, or disability informations of the patients. And personal history, we can get the ICD-10 codes and or Aristotle codes of the drugs. And on the other hand, we can check the drug actions, right? Because some of the patients can use some critical drugs, which is very important for life insurance. And this information may not be in the clinical note, right? So we need to check the drug information, like antidepressant, right? So we can use chunk mapper models for this. Or if the detected entities are related to the family members, we can use assertion models again. For the lifestyle, we use NER and assertion models together, and detecting diseases is the most important part of this medical risk factors, and we used NER models. Actually, we used more than one NER model together to extract these all disease entities. And then we create the Spark NLP pipeline. Spark NLP pipeline can be fed with the data that can be processed by Spark NLP. So if the data, the unstructured data in TXT, JSON, or any other formats that Spark supports, we can process those files. So if they are in PDF or image format, again, Spark OCR, which is another licensed component of Johnson Labs, we can use Spark OCR first, then we get all the data that we can provide to Spark NLP pipeline. First, we get the named entities in our pipeline, then feed them to the assertion models or resolver models. In here, we didn't use release and extraction models, but we use assertion and entity linking models, entity resolution models. This is the same. After that, at the end, we created a tabular data that we can do some more analysis easily, so that we converted our unstructured data to a tabular data. Okay, let's jump into the notebook. We have a Databricks notebooks to show you how we can implement all these to on a real world data. So here are the topics that we will focus on, and we start our Spark session, and we have some helper functions here. We used empty samples clinical notes here, which is an open source data that you can easily reach, and we downloaded those clinical notes, and we have 5,000, nearly 5,000 clinical notes. But there, as you can see here, their specialties has been defined here. So when we check the specialties, we saw that some of them are not appropriate for using the medical for life insurance. So we just picked 10 of them, the most risky diseases, risky medical specialties, actually. And for making the notebook faster, we picked only one clinical note from each medical specialties. So at the end, we have 10 rows which represents different patient notes, as you can see here. Then we create a Spark data frame with our data, and deep learning and machine learning models cannot understand the context from the sentences, the human readable sentences. So we need to vectorize them first. So that we use embeddings clinical model here, which we trained many of our NER models with this embeddings model. And then we started to implement, we started to load our medical NER models. So the first one is NER GSL model, which is a flagship model of Johnson Labs, and it has it can detect 80 different NER entities, and also it was trained with in-house data sets by annotating our clinical experts for 6 months. So we will just pick the related entities for our tasks from this model. And also to make the pipeline stronger, we used some other NER models, and to drop the unrelated labels, we define some whitelists here. And then we load our models. You can add any NER models here to make your pipeline stronger, or add some additional rule-based approach, like contextual parser approach. Here we showed you as an example to detect the age entities, to make the pipeline better to detect the age entities. We defined the contextual parser here, which we define some rules for detecting age entities. And also this is a context-aware rule-based approach, very special for Spark NLP. And then we renamed some of the labels, right? Because some NER models has different labels for detecting some of the entities, like drug ingredient and drug brand names. We merged them under the drug label, and all the disease labels were collected under the disease label. So we renamed all our labels here and fit this dictionary to our chunk merger approach, which merges all the chunks detected by the NER models together. So we build up a pipeline here. After that, you can also visualize your data on a small amount of data, on Spark NLP display library. We have NER visualizer, assertion visualizer, or resolver visualizer, and check if the model you created works well or not. If some of the entities cannot be detected that you're interested in, you can add some more additional NER models or create some rule-based approach for detecting those entities. As you can see here, the disease entities or procedures and meta status and some behaviors are detected correctly. After transforming the data on the model, we have converted our unstructured data to a tabular data, as you can see here. But this is not enough. So when we pivot the table, all the rows, we converted our table to a pivot table that each rows represents a clinical node, and each columns represents the entities detected from the clinical nodes. Okay, so the disease entities are in this column, and drugs are here, or weights are here. After that, if you want to determine the genders of the patients, you can use gender classifier models, and as a new column here to check the genders of the patients. And then we can use ICD-10-CM resolver models, which is very popular for insurance companies or hospitals to check the disease entities are billable, has a billable code or not. Okay, so it can return the billable information of the disease entities. So when we feed the disease entities to the resolver model, we are able to add as a new column the ICD-10 codes and the resolution of the disease entity. So we have normalized them, right? We if some allergy and allergies entities are in the disease column, so we just converted all of them to normalized all of them to as allergy. Okay, and we can do that. We can do the same thing for drugs by using the Ariston resolver, as you can see here. After that, we added the drug actions. We checked the drug actions. As I explained before, there's no information of these drugs, which drugs are used for what, right? So we can map them to, we can use them, we can map those drugs, check their actions by using chunk mapper models. And if you want, some of the detected entities are not related to the patient, because in the clinical notes, we saw that the entities are, there are some family history sections. So those entities are not related to the patient. They are related to the patient family, right? So making better analysis, we can assign family label to the diseases in the clinical notes by using assertion status model, like hypertension or heart problems. These diseases are not are related to the patient family, not the patient. So we also get the ICD-10 codes of the family member diseases, then to normalize them again. Then we check the alcohol, tobacco, and substance behaviors. Again, we use assertion status model with NER model. We filtered only the alcohol, substance, and smoker entities, then feed them to the assertion model, check if they are present, past, conditional, or not. If they are present, we labeled them as true. We added as a new column here. We labeled them as true. If they are not, the results are false. So we also have some classification models for detecting some of the alcohol, tobacco, and substance use, substance behaviors. We have social determinants of health classification models for this. Then here's an example of the pipeline that we can use all these models together. And when we feed the sentences, we can get the results of these behaviors. They can classify those texts. So it's analysis time. So making good analysis, it all depends on the data amount, right? So we only worked on 10 different clinical notes, which is not enough for making good analysis. So we prepared another data frame with all data that we defined as risky diseases, risky specialties, okay? So we have a big data now. It's enough for making analysis. And then here is the analysis start. Yeah, let's check race, ethnicity, and behavior analysis. And we did some post-processing here to map some of the keywords to to the main topics that we are interested in. And when we check this table, black and white people have some substance, alcohol. We can see their substance, alcohol, and tobacco status. And for making the gender-based analysis, let's check the gender behavior analysis. And this is our result, right? Also, gender versus behavior counts of the patients who has obesity. Very interesting, right? And also, so we get the rabbit from the head, right? So it all depends on the questions that you want to ask, that you need. When we want to do some analysis on the diseases, these are the most common diseases in the clinical notes that we use. Also, when we normalize them, so they can be in different formats, like tumor and tumors are different, right? So here, but when we normalize them under only the tumor, they all counted together. So as you can see here, stroke and bleeding and stroke, their order has been changed. So this is necessary for making good analysis. And these are the disease pairs that are seen, that are most common together, seen together. Hypertension and diabetes diseases seen together. And what kind of diseases do patients who drink alcohol have? Hypertension. So we can answer these kind of questions right now, but we cannot do that on unstructured data, right? And we can do the same analysis on drugs. What are the most common drug pairs that are used together, like on the normalized names, these drugs used together. And the most common actions of drugs, analgesic, anti-allergic, and antidepressant are the most common drug actions. What kind of diseases do the patients who use analgesic drugs have? Hypertension, again. So what are the most common drug action pairs? Yeah, these are the most common drug action pairs. And hypertension is one of the most common disease that we see so far. And when we want to focus on this disease, we can do some sub-analysis, right? What diseases do family members of the hypertension patients have? So hypertension again. Very interesting results, right? So, and what drugs do hypertension patients use? The aspirin, effervescent oral tablet. Yeah. And behaviors of hypertension patients, most of them use tobacco, right? And alcohol. Yeah, this is the end of the analysis and the notebook. I hope it gives some idea for making how you can extract or automate the extraction of medical risk factors for life insurance underwriting. Thank you.